Hello, and welcome to a short video presentation on the Santa Rita Connection project. My name is Chris Ortiz-Pino. I work for Tucson Electric Power, and I'm a project manager of siting, outreach, and engagement assigned to this project. It's important to start from the beginning in every presentation to ensure we all have a common understanding of the project. Thus, we start, as we always do in our project meetings, in describing how power gets to where we need it, transitioning into the purpose and need of the Santa Rita Connection project. There will then be a description of the planning and siting process and where we are in the process currently. From there, we'll get into the details of our recently completed suitability assessment and the resulting refined segments. And finally, we'll touch on the required approvals and anticipated timeline for the project. For simplified context on this project, here's a quick sketch of how electric power is distributed through the electric grid. It begins at generation. That could be from a conventional power plant or from a renewable resource such as solar or wind. From there, the energy is stepped up to a higher voltage to be more efficiently moved through transmission lines over long distances. At this point, the transmission line enters a substation, where the voltage is stepped down or transformed to a distribution voltage. Distribution lines then bring the power to homes and businesses, where again, the voltage is stepped down to a level that can be consumed, such as 120 or 240 volts. So what is siting? You are no doubt familiar with this term. However, we want to make sure that the term is understood in the context of this project. So when we refer to siting, it's simply the process of determining the exact route or location where a transmission line will be built between two or more points. The proposed Santa Rita Connection transmission line will extend from the existing Sonoran substation on Swan Road, just south of Oldvale Connection Road, to the proposed Santa Rita substation, which will be located on the South Country Club Road alignment, just south of Santa Rita Road. The proposed Santa Rita substation will support service reliability for distribution customers in Sal Rita and homes and businesses as far north as Sal Rita Road. The purpose and need of this project are threefold. Increasing capacity. The new 138 kV transmission line and Santa Rita substation will provide greater capacity to help meet the current and future energy needs of the community. System reliability. The addition of the new transmission line will enhance the regional grid and provide redundancy and stability. With these system upgrades, TEP will be able to retire an older 46 kilovolt substation and the removal of a temporary mobile substation in Sal Rita. The 138 kV transmission line will be built using steel monopole structures. Most would be between 75 and 85 feet tall, with wire spanning anywhere in the range of 600 to 1,000 feet between poles, depending on topography. Let's take a minute to talk briefly about our siting process and describe where we are currently for the Santa Rita Connection project. This process is designed to be transparent and instill trust from the public that we are doing our due diligence, that we listen to feedback, and that we incorporate that feedback honestly to build the most environmentally compatible project that we can. The comprehensive process involves 5 phases, where at each phase we either seek public or stakeholder input, or we are incorporating the input received into our analysis. Every step in the process is about learning from the community, refining our understanding of the project, and finding the best solutions to the challenges presented. At this point in the project, we are at the tail end of Phase 3, where we conducted a suitability assessment of all of the preliminary segments that had previously been identified in Phase 1. The suitability assessment utilizes the data collected in Phase 2 to develop suitability models using GIS, which we then use to identify segments which are more suitable for a transmission line. In Phase 4, the compatibility analysis will then utilize evaluation criteria defined through state statute and bolstered by feedback from the public and stakeholders to analyze each of the line segments still being considered to determine which are more compatible with the natural and built environment as well as local values. The most compatible route will be identified as TEP's preferred route, but other routes may be identified as compatible and considered as viable alternatives. Those final routes will be presented to the public and stakeholders during Phase 5 for review and evaluation. These final route alternatives will be included in the application for a Certificate of Environmental Compatibility to the Arizona Corporation Commission. The next slides were presented back in November during our public open house as part of phase 1 of the siting process. The study area was defined based on the known start and endpoints of the project in the north and south, as well as the presence of existing and approved infrastructure. From here, we began identifying opportunities and constraints within the study area. The opportunities that we identified followed linear infrastructure, such as existing or approved utility corridors, roads, section lines, as well as washes. The constraints that were identified surrounded existing residential areas, developed solar fields, and lands managed for conservation. We then looked at all of the opportunities that were identified and evaluated them through an engineering lens. If it was determined feasible to construct a transmission line within the area of opportunity, we added a line to the map and called it a preliminary segment. These preliminary segments formed the basis of the suitability assessment. On the right-hand side of the scale, we represent preliminary segments. To become a preliminary segment, the only criterion that were assessed were based on cost, maintenance, and constructability. As we moved into phase 3, the suitability assessment, we began considering additional factors important to the community and environment, balancing them with constructability, maintenance, and cost to find the most suitable path for a transmission line that satisfies the need for the project. If you have thoughts or additional factors that we should be taking into consideration on the siting evaluation, please let us know. This is the reason we have sought to engage with you. The suitability assessment utilizes the data gathered and input received to construct criteria models in GIS. Those criteria are then combined to create composite models where each criteria model is given a weight based on the intent of the model. Once the models are created, a GIS tool is run that finds the path of highest suitability. The results carry forward to a ground truthing and field verification process. The end results of the process is that less suitable segments are eliminated and the segments that remain carry forward for further evaluation. I mentioned criteria models in the previous slide. These graphics represent the output of each criteria as a heat map describing areas of higher or lower suitability. Combining all 8 of the criteria models, different weights were applied to each criteria to illustrate the suitability of segments based on different preferences or priorities. The 4 composite models we created were a balanced compatibility model weighing each criteria equally, an environmentally preferred model weighing biological and cultural resources more heavily, construction and maintenance preferred model weighing cost, construction, and maintenance more heavily, and a public and stakeholder and agency preferred model, which weighted input from the public, mainly the importance of scenic and visual resources and proximity to residential areas, more heavily. This is a closer look at the heat map that each composite model created, showing areas that would be most and least suitable for a transmission line. At the end of the suitability assessment, we looked at the results and visited each one in the field with subject matter experts to verify the results of the data analysis. Ultimately, 84 of the preliminary segments were removed, and 76 segments were carried forward to the next step of the process. These are the refined segments that you see on the map that will be analyzed in phase 4 of our compatibility analysis. Under state law, before TEP can construct the transmission line we are proposing, we need to receive a Certificate of Environmental Compatibility, or a CEC, from the Arizona Corporation Commission. The planning and siting, together with the public outreach and engagement that we are currently undertaking, is all in anticipation of preparing an application for a CEC. We are currently planning on filing that CEC application with the ACC in April of 2026. That will be followed by a public hearing before a group called the Arizona Power Plant and Transmission Line Siting Committee, which will make a recommendation to the ACC to either approve or deny a CEC for this project. We expect that hearing to occur in May, with the ACC making their final determination at some point thereafter. Our next public open house will be held on Wednesday, March 4th, 2026, where we will be presenting the alternative routes determined from Phase 4 compatibility analysis. We look forward to your participation and input on which alternative should be carried forward as our preferred alternative. The meeting will be at the Desert Diamond Casino in Rita at 1100 West Pima Mine Road, Rita, Arizona 85629.